All right, let's go ahead and look at the 5-8 problems. These are the ones where the answers are going to turn out to be inverse trig functions like arcsine, arcsecant, or arctangent. So we're going to look at three of these. Okay. Let's go ahead and look at number 3. When I'm looking at that, I see a square root of 9 minus x squared in that denominator, but I don't see an x anywhere else. So it's not just a regular U substitution type problem. That makes me think it's one of these inverse trig functions. And I know it has a square root, so it has to be arcsine or arcsecant. This one looks like an arcsine to me. Okay. All right, with number 5, I take a look at that. I see the square root. This looks kind of arcsecant-like because if I did the derivative of the part underneath the radical, it would be 8. The part underneath the radical would have an x in it, so you might think, oh, that's going to work. But the x that you see here is not an x that goes with the dx. It's like an x in a denominator. So it's really not going to be the chain rule situation. It's not going to be a substitution type problem either. So I'm thinking that's going to wind up being that arcsecant because that formula has a little something outside and a little something underneath the radical. Then we'll do one of the other two. Why don't we go ahead and look at, trying to see which one's harder. 6 has the issue of the constant. 11 has the issue of a t squared instead of just a t. I'll go ahead and do one of these. Why don't I do 6? So we'll do 3, 5, and 6. Okay. And 6 doesn't have a square root on it. And if I did the derivative of the denominator, it would be 18x, and I don't see an x up there where the 12 is. So it's not just like a natural log type problem, it's something else. And then I realize it fits the arctan formula there. All right, so with question number 3, I would do a little rewriting just to be able to compare it to the formula that I know. So I see how the 9 would be 3 squared, and then I already have the variable part written as something squared, and then I'm just going to move that dx off to the side. So this one fits perfectly the arc sine formula. So, the arc sine, doing the antiderivative of, and the way they write it is doing the antiderivative of, they put the du up there on top over the square root of, and you have your constant first minus your variable part. Okay. Doing that turns out to equal arc sine of u over a plus c. Okay. So when I'm looking at this, the u is really just an x, and the derivative of it would just be 1. So I'm safe in just going ahead and applying the formula. I think you can tell by comparing it to the formula that a is 3 and that u equals x and that it fits that pattern. Okay, so let's go ahead and just write our answer. It will be arc sine. Okay, the constant was 3, the u was x, so it'll be x over 3. Okay, and then plus c, and we're done. Okay. All right, now on question number 5, I'm looking at that one. I'm trying to rewrite it so I can compare it to the formulas we have. And I can see that it would be 2x squared minus 1 squared under that radical. But then it's just an x right there, where the one for arcsecant looks like this. The arcsecant one that turns out to be arcsecant has the u, and then the variable part is first minus the constant part squared. Okay. And the answer turns out to be 1 over a, and then it will be arcsecant of the absolute value of u over a plus c. So that's the formula I'm trying to use. So on this one, I'm going to do a little u substitution. So let me erase this over here on the left so I can do my little u over there out of the way. Okay, So I'm going to let u equal 2x. If I do, du would equal 2 dx. Okay. So there's a couple ways you can handle this. Normally I have you multiply both sides by 1/2 to get the dx by itself, but it might be helpful for you to see this other approach on this one, because like when I'm comparing to the formula, like when I'm looking here, I want that to be my u. I said that u was going to be 2x. Well, then out in front of that radical, I'm supposed to have a 2x, and I don't have it. So I can make it happen by putting a 2 down there as long as I multiply on top by a 2. Okay? So that's always okay to do, and that little adjustment helps me fit this formula a little bit better. Okay, so then what I've got, once I put the u's in, is a u and a square root of u squared minus 1 squared. So the denominator is what I need it to be. And then do you see this 2 times 1, which is 2, and that the 2 right there, this part, together with that dx part, do you see how that's really du? So this part right here times that part, this would really be able to be written as 1 over 2x with the square root of 2x squared minus 1 squared, and that 2 dx could be over here. That would say the same thing. So when I'm looking at things, I'm noticing that I can replace 2 dx with du. So that's basically what I did. I put the u for here, the u for the 2x here, and I replaced 2 dx with du to make it look like the formula. I usually like my du off to the side, but the way the formula is written, when you look at it, has that du up on top. But it means the same, right? It means the same as 1 over u square root of u squared minus 1 squared with a du right here. Okay. All right, so now I'm noticing that I've got exactly what I need. So this right here should equal 1 over a, which is 1, arc secant of the absolute value of u over a, which is 1, plus c. And 1 over 1 is 1, so this is arc secant, and the absolute value of u is 2x, so I'd put the 2x back in, and there you have it. That's going to be my answer on that one. Okay. All right. So the arc secant is definitely the hardest type. Okay. Let's do one of these that turns out to be arc tangent. Let's look at number 11. All right. So the first thing you want to do is try to look for pieces that match what you're expecting. All right. So when I'm looking at this, I can see the denominator is t squared plus 5 squared. And then I have this t dt. I'm going to just put it over here to the side and leave a 1 on that. So I'm going to work on, in a minute, trying to figure out what to use for my u and what else I need to do to take care of this. Okay. So let's add the one for that turns out to be arctan into the mix. So that one says you have a squared plus u squared in the denominator with a du. And if you do, oops, that's not an equal sign, that's a squared. If you do, that's going to equal 1 over a arctan of u over a plus c. Okay. So if I can make the problem we're trying to do look like that, then I can use the formula to figure out the answer to my question. So that's what I'm going to work on. So for this, I'm going to let the u be t squared. Then du would be 2t dt. Okay. All right, now something that's bothering me a little bit is when I look at the tangent formula, it's kind of like arctan formula. It's kind of like the arcsine formula. The number is supposed to be second. The variables, the number is supposed to be first, I mean. The variable is supposed to be second. But on number 11, the variable term is first. But you see how it's a plus sign? Wouldn't that be the same if they switched that around? So it doesn't really cause a problem on the tangent like it does if you have a arcsine situation or an arcsecant and the U and the A are in reverse positions. You can't just switch them around. That winds up causing a problem. Okay. So it probably would have been good for me to notice that first. And so I'm going to be reminding you of that here. So this is really a 5 squared plus a t squared squared with that t dt off to the side. Okay. And so I can erase that and have a little more room. So I'm going to try to do replace all the stuff I need to replace. All right. So when I go to do that, what I'm noticing is that this t dt is here. But what I'm noticing over here is that extra little 2. So I'm going to have to get that moved out of the way, or do like I did on one of the earlier problems and figure out a way to get a 2 right here, which I could do if I could divide by 2 somewhere. Okay. All right. So now we're going to wind up using the formula. All right. Because I have this pretty much matching, looking like maybe it's going to match the formula. So I'm going to start plugging in everything, all the U stuff. So wouldn't I wind up, to make it look like this one, wouldn't I wind up having the 1 over, and then I've got the 5 squared plus U squared. Okay. And then the t dt I can replace with 1/2 du. Okay, so I have a 1/2. Then I have the 1 over 5 squared plus u squared du. All right, so now that pretty much looks like I need it to look, except for I have that constant 1/2. So I'm going to be bringing the 1/2 down because it's a constant that I'm just moving out of the way. Then I'm going to use the formula up there to integrate, think about what that looks like when I integrate it. So isn't that going to be 1 over my a, which is 1 over 5. A is 5, right? So the a would come from here. Okay. And then I'm going to do arctangent, and it's going to be u over the a, which is 5, plus c. And then my final step, if I can squeeze it in on this blue part, would be 1/10, 1 over 10, arctan. Put the t back in, so that would be t squared in place of the u over 5 plus c. And then that would be my final answer. I hope you can see that. Okay. So these are the basics of the 5/8 problems. These are the ones they recommended that you look at. And you can do 6. It's a little easier than the others.